So now let's talk about more assembly evaluation features. And I'm going to start with hole alignment. And for that, I'm going to use this pipe joint assembly. Now in this assembly, we have the top portion of this pipe joint, bottom portion of this pipe joint, and also several nuts and bolts here. Now I'm going to start with this bolt and nut, and I'll select and hide it. I'll select the nut and I'll hide it as well. And finally this circular pattern of nut and bolt, and I'll just suppress it so that we are left with only these two joints. Now, when you inspect these holes visually, it may look like they're perfectly aligned, but well, on closer inspection using the tool, hole alignment tool, it may end up with errors. So it's always important to just check the hole alignments properly using the hole alignment tool if you have holes in your assembly. So I'll go to this hole alignment tool, and here you need to specify the maximum deviation which is acceptable. In this case, I'm using 10 mm, the default value, and any hole misalignment within this 10 mm value will show up in our result. So if the hole alignment between center to center is less than 10 mm, it's going to show up. So with that, I'll click on calculate. And here we are, we have got several hole misalignments. So the deviation is 0.27 mm between two holes. And if you select it, it's going to show that, well, all of these holes are actually misaligned. You can expand the tree and see the misalignment. So here we have this 12 mm hole on the top pipe. And then we have another one with again 12 mm hole, but despite equal diameters, we have a 0.27 mm deviation. So that could be probably because the distance of this hole from center is off for both the pipes. Now let's check it. So I'll just close it, and here I'll evaluate the distance. For that, I'll go to measure and I'll select this hole and then maybe this face. And the distance from center of that hole to center of this one will show up here as 35.8 mm. All right, now let's repeat it for this bottom pipe. So I'll go to measure and I'll just select this bottom face right here, and well, I'll just cancel it and repeat it again. So measure and closely, I'll just select this face and I'll select this face right here. And now this black distance, as you can see, is 36. So in fact, we do have a deviation of 0.2 mm. So in the previous case, it was 35.8. Now it is 36. So we just need to fix the distance for this bottom pipe. Now to do that, I'll select this bottom pipe, right click, and I'll select edit part, and I'll just edit it right here. All right, so expand this, and here we have the circular pattern and the hole. Here's the sketch, and you can now clearly see the distance as 35.8. So that's what we need to modify. So I'll simply double click this sketch and I'll just make it 36 and enter. All right, so this is now modified. We can rebuild this and we can now exit out of this. So exit out of this part and we are done. Now it looks like it should work, but still we have a problem. It still doesn't look like it's properly aligned. And that's just because of the mate. These two are not properly concentric. So we just need to do that as well. So I'll go to assembly and I'll select mate, and I'll select this face right here and this face right here. And I'll just ensure that these two are concentric. Now that they are properly aligned, we will be able to apply the concentric mate. Once you are done, now it should be properly aligned. So let's evaluate once again. So go to evaluate, hole alignment with 10 mm. I'll click on calculate, and we don't have anything, no misaligned holes, and that's a good result. So in this way, you can check misalignment of holes, and you can also fix these errors. So I'll now cancel this. Now let's go to the next one. So I'll go to window, and here I'll select full assembly of our drawer. Now in this case, we have, well, several different components, and I will start with the clearance verification tool here. We have this clearance verification tool, using which you can check the clearance between different components as well as different faces of the component. Let's start with this. Now here we have two options. You can either select a component or you can select face. In this case, let's start with faces. So I'll select face and now select the faces. So as you can see, we have a gap between this drawer face as well as this cabinet right here. We want to just measure this gap. And to do that, I'll select face, and here I'll zoom in and I'll select this face, and then I'll select this face. And now specify the maximum deviation which is acceptable, and any value within this limit will show up. So again, I'll keep the maximum deviation of 10 mm and I'll select calculate. But before doing that, Also make sure that selected items are checked, and then SolidWorks will only show the deviation or this clearance between your selected components, which are these two. So click on calculate, and it looks like we have a clearance of 6.72 mm. So that's the clearance. Now we have the same set of options right here, which we saw previously in the interference detection. For example, in the uninvolved components, you can change the visual style. You can make them wireframe, hidden, transparent, or you can use the current style. In this case, I think transparent will work. So I'll just keep transparent selected. Also here, if you want to make fasteners folder, you can just do that. You can also make parts under evaluation transparent just by checking this one. And in this case, these are the two parts which we are evaluating, so it will be transparent. Everything else will take the visual style as specified here. And you can also check this box if you want to ignore any clearance value which is exactly equal to our specified value. Well, it won't matter in this case, so I'll keep it unchecked. Again, if you want to treat subassemblies as component, check this one, and you can also check this option to show any ignored clearances. So if there are several clearances and you want to just ignore them, you can select and click ignore, but just by checking this, you can bring it back in this list. All right, let's check more clearances. So this was the face. Now let's select the component. So maybe I'll just cancel this out and I'll repeat it one more time from scratch. So I'll go to clearance verification, and now I'll select component. And this time let's select these two components. So we have this door panel and then this complete cabinet. And again, as you can see, there is a gap. Now we want to evaluate the gap between these two components. So for that, I'll select component and I'll select this panel and this entire cabinet. All right, I'll keep this selected item checked. Maximum value of 10 mm, I'll click on calculate. There we are. It will show the clearance of 3.61. So that's the clearance between this panel and this main component right here. Now you can use the measure tool as well to measure all of these distances. But if you want to use measure, then you need to select every single face or every single edge or even point if you want to just check the clearance. What if you want to check the clearance of entire assembly? In that case, you can just simply click here and you can select a component. For example, we have two of these, so I'll just clear this and I'll just select this component right here, this panel. Now, with respect to this panel, it will show the clearance value of all the components. So I'll click on calculate and here we are. So with respect to this panel, the clearance is 3.61. For this, and for all the other components, it's coincident right here. But yes, there are other components where we have different clearance values that's going to show up. So in this way, you can check the clearances and it won't list any clearance which is more than 10 mm. So if the clearance is beyond that range, it won't show up. But if you want to, you can increase this number to, let's say, 500. And you can calculate it one more time. And now the list will be much more bigger because it will show every single component and the distance of every single component from your selected one. So with just one single click, you can check clearance of several different components using this. So now I'll cancel this. And finally, let's see what assembly visualization is. So in this case, we have this assembly with several different components. Let's click on this assembly visualization and it will give you an idea of number of components that we have. And if you have already applied the mass properties, it will just show you the mass and other information related to your assembly. For example, in this case, we have two colors to indicate different components. And if you have several components, all of these components will take slightly different color. If you want, you can add even more colors. For example, I'll add one here at the center. So I'll just click here and I'll maybe select yellow. And now we have, well, three colors and the color of every single component will change between these ranges. Then we have this bottom channel, which is added twice. So we have two instances of this. We have just one cabinet, we have 6 drawer screws and so on. So it will show every single instance of it. So we have 24 hinge screws, that's right here, and also mass. If, as I mentioned, if you have added the mass property, it will show that as well. So this cabinet is approximately 11 kgs. This is 3.5 kilograms and approximately half kilograms for these two. So this entire cabinetry is about 15 to 16 kilograms in mass. So you can check that. Not only that, you can also change the way this is displayed. So you can just click here to switch to the nested view like this. And you can also click again to just change it to the flat view. You can also group or ungroup this view. Right now it is completely ungrouped and every single component will show up. For example, hinge screw, there are several and it will show every single one of these. You can group it and all the hinge screws will be grouped together. Hinge on the right side will be grouped together and so on. So with that, I'll now cancel this. And these were the evaluation options of assembly.